All right, so as we read through the text, please remember to annotate along the way. That means that we are underlining important information. We're boxing keywords. And if we have a question, we can put a question mark. Go ahead and put your name up here and whatever period number you have science, please. All right. So let's go ahead and get right down to it. Please remember that you should be annotating with me as I read out. What is energy? Energy makes change. It does things for us. It moves cars along the road and boats over the water. It bakes a cake in the oven and keeps ice frozen in the freezer. It plays our favorite songs and lights our homes. Energy makes our bodies grow and allows our minds to think. Scientists define energy as the ability to do work or cause change. Let's add that in. All right, forms of energy. That just basically means types of energy. There's potential forms of energy and kinetic forms of energy. Energy is found in different forms, such as light, heat, sound, and motion. There are many forms of energy, but they can all be put into two categories: potential and kinetic. Potential energy forms. Potential energy is stored energy and the energy of position, or gravitational potential energy. There are several forms of potential energy. Okay, the first one is chemical energy. Chemical energy, sorry about that. I'm gonna have to remember to move that up. Chemical energy is energy stored in the bonds of atoms and molecules. It is the energy that holds these particles together. Biomass, petroleum, natural gas, propane, and the foods we eat are all examples of stored chemical energy. So, we know that those are fossil fuels. So fossil fuels count as chemical energy. Elastic energy. Elastic energy is the energy stored in objects by the application of force. Application just means adding, so by the application of we could just replace that with the word adding. Compressed springs and stretched rubber bands are examples of elastic energy. Nuclear energy. Nuclear energy is energy stored in the nucleus of an atom. It is the energy that holds the nuclei together. The energy can be released when the nuclei are combined or split apart. Nuclear power plants split the nuclei of uranium atoms in the process called fission. The sun combines the nuclei of hydrogen atoms in a process called fusion. So fission means splitting the nuclei of atoms apart. Fusion means combining the nuclei of atoms together. Gravitational potential energy. Gravitational potential energy is the energy of position or place. A rock resting at the top of a hill contains gravitational potential energy because of its position. It has the potential to fall down the hill and do some damage on the way. Hydropower, such as water in a reservoir behind a dam, is an example of gravitational potential energy. Now let's take a look at some forms of kinetic energy. Kinetic energy is motion. It is the motion of waves, electrons, atoms, molecules, substances, and objects. Electrical energy is the movement of electrons. Everything is made of tiny particles called atoms. Atoms are made of even smaller particles called electrons, protons, and neutrons. Applying a force can make some of the electrons move. Electrons moving through a wire is called electricity. Lightning is another example of electrical energy. Radiant energy, or electromagnetic energy is what we're going to be calling it, is energy that travels in vertical or transverse waves. Radiant energy includes visible light, X-rays, gamma rays, and radio waves. Solar energy is an example of radiant energy. So, off to the side over here, let's take a look at what vertical waves look like. So I'm going to pretend that here's my sun. When we say vertical waves, this is what we mean. The waves are traveling in this direction, and they're vibrating in this direction, up and down, like this, as it moves forward, okay? So we're going to say the wave vibrates this way and travels this way, okay? All right, let's take a look up here at thermal energy. Thermal energy, or heat, is the internal energy in a substance. It is the vibration and movement of the atoms and molecules within a substance. The more thermal energy in a substance, the faster the atoms and molecules vibrate and move. Geothermal energy is an example of thermal energy. Mechanical energy is the movement of objects and substances from one place to another. Objects and substances move when an unbalanced force is applied according to Newton's laws of motion. Wind is an example of motion energy. So is a car going, and we're going to be calling that mechanical energy. Let's take a look at sound energy. Sound energy is the movement of energy through substances in longitudinal or compression/refraction waves. Sound is produced when a force causes an object or substance to vibrate. The energy is transferred through the substance in longitudinal wave. So here's what that looks like. So longitudinal waves look like this. They'll get farther apart and then compress. So basically, they're traveling in one direction. So it travels in this way. And then the vibration happens between the compression of one end and the compression of the other, kind of like a spring, okay? So this is how the vibration of the waves occur. All right, let's go ahead and flip the paper over. Conservation of energy. Your parents may tell you to conserve energy. Turn off the lights, they say. To scientists, energy conservation is not just about saving energy. The law of conservation of energy says that energy is neither created nor destroyed. When we use energy, it doesn't disappear. We can change one form of energy into another. A car engine burns gasoline, converting the chemical energy in gasoline into motion energy. Solar cells change radiant energy, or light energy, into electrical energy. Energy changes form, but the total amount of energy in the universe stays the same. Efficiency. Energy efficiency is the amount of useful energy you get from a system. A perfect energy-efficient machine would change all of the energy put into it into useful work. a technological impossibility today. Converting one form of energy into another form always involves a loss of usable energy. This is where our G4 project comes in. We want to take a look and see where energy is being wasted or lost, and maybe figure out how to harness some of that energy. Ooh, hang on, the screen went off. There we go. Energy wasted or lost. How can we save that energy? How can we use it to go towards something else? Most energy transformations are not very efficient. The human body is a good example of this. Your body is like a machine, and the fuel for your machine is food. Food gives you the energy to move, breathe, and think. Your body isn't very efficient at converting food into useful work. Most of the energy in your body is transformed and released as thermal energy. That's heat. You can really feel the heat when you exercise. This is very much like most energy transfers. The loss of usable energy is often in the form of thermal energy or heat. We might think about brainstorming some ways to conserve the heat. Maybe we could use the heat for something else. There are ways to turn thermal energy into electrical energy. Some people have figured out how to create a sleeping bag that the body heat from being inside the sleeping bag is used to charge a phone and to make electricity. It's very fascinating stuff. All right, so we're going to go ahead and skip this part. We're going to be learning about sources of energy later on. We're going to go down and talk about electricity because this is something that we've been learning a lot about. Electricity is different from the other forms of energy sources because it is a secondary source of energy. We must use another energy source to produce electricity. In the US, coal is the #1 energy source used for generating electricity. Electricity is sometimes called an energy carrier because it is an efficient and safe way to move energy from one place to another, and it can be used for so many tasks. As we use more technology, the demand for electricity grows. That's why we focused so much of it on the beginning of this class, is because electrical energy is super important for modern life and modern technology. All right, so what you're going to do is you're going to take the information that you read about in this text and you're going to fill in the graphic organizer that we glued into our evidence notebook. For example, notice that one side of the graphic organizer is for kinetic energy forms. The other side of the graphic organizer is for potential energy forms. Okay? So what I'd like you to do is up here where it says potential energy, you're going to write the definition. And then up here where it says kinetic energy, you're going to write the definition. Now, inside of each one of these different sections, you're going to write the name and definition of the different forms of kinetic energy. So we might say kinetic energy forms. And then in each of these 4 boxes, you're going to write the name and definition of the different forms of potential energy that you read about. So potential energy forms. I'll go ahead and do the first one for you. So let's look back here to see if we can find the definition of, let's start with potential energy. Potential energy. So we boxed the key word. Potential energy is stored energy. So let's go ahead and write in stored energy. And then let's see if we can find the first of these 4. Potential energy. Looks like we've got chemical energy as the first one. So all of these are different forms of potential energy. So let's go ahead and put chemical energy in the first box. And let's go ahead and define it. So we're going to say it is energy stored in the bonds of atoms and molecules. Energy stored in the bonds of atoms and molecules. And that's it. We're just going to write a very simple, quick definition. Please be sure to leave space in each one of these for later on. And so you have the option of working by yourself or with your partner to go ahead and finish filling in all of the definitions and names of the different forms of potential energy and the different forms of kinetic energy. Please let me know if you need help.